Hey everybody, this is Mark from RGB CRT. This video is not about CRT monitors. This is actually about a light meter that I designed and 3D printed and made available on printables.com. This video is to show people how to put it together properly and a little bit how it works. So let's get started. All right, here we go. Here's the light meter. It's on, it's working. It uses a little lithium battery. You can tell by the orange tape that I've already ripped the cable off of it and had to solder it back on. My bad. It's a very simple little interface. There's you can't really see it too well on the screen because of how bright it is and the dynamic range of this camera. But there's a little button here that lets you go subtract minus from the aperture value, which is the default mode. And there's a plus button to add to the aperture value. And there is a menu button that you can hold down, which, well, again, you can't really see the menu there, but there's the middle button will take you to an ISO menu, and you can exit or change the ISO here. And the top button will take you to a mode menu where you can change between aperture priority and shutter priority. So in case you didn't want to use aperture priority, you can switch to shutter priority depending on your shooting conditions. All right. Exit out. We'll exit out again. And this is the second display mode, which basically just tells you the measured values. The other mode actually tells you what you should be using. So you just tap the top button to change it. And if you hit the bottom two buttons, plus and minus at the same time, the screen should shut off, save you some battery power. It's still working though. The sensor's still accepting light and it's still doing calculations and everything's still running, but you can just turn off the screen, turn it back on. Cool. Again, the sensor is at the top. It's that little window right there. It's a VEML 7700 sensor, and this device can also be powered by USB-C. Let me tilt it so the light catches it. There you go. USB-C port, and that USB-C port will charge the lithium battery, so you can just leave the lithium battery hooked up all the time. But I wouldn't, obviously, if you're not using the light meter, disconnect the battery. Don't let it sit there. This OLED screen will suffer burn-in if you leave it on too long. Over time, it's just going to happen one way or another because the objects on the screen don't wiggle or do anything. So, yeah, that's just how these screens work. Anyhow, let's take this apart. I'm probably going to have to fast forward through it because it will take a while. But let me do that real quick. All right, let's disconnect the battery first. Pull it out from that end. Be careful. And you can just slide the battery out like that. Cool. All right. And let's start taking it apart. All right, before I start fast forwarding, you do want to unscrew the quarter 20 screw from the bottom. This is just plastic threads. If your 3D printer is capable of printing it like my Prusa is, it works just fine. Just don't over tighten and you'll be fine for a very long time. There are 4 screws holding the top part on, and they're all M2.5 screws, and they're going into captured nuts. And there is also on the sides, right here, right here, and on the other side there's little snap lock parts that grab onto the edges, and you can kind of tell I've already pried this top off at least once. You can kind of tell that where that snap thing was, and I had to push pretty hard, so I deformed this top part already. But when you first print it, if you put it together correctly the first time, you won't have any issues. All right. All right, the top is off, and you can see the little sensor board with the sensor facing up and connected by a little quick connector. I forget the Stemma QT. It's a Stemma QT connector. It's 50 millimeters long, so this is what it looks like when you get one new in the bag. This costs like $1, I think, from Adafruit. You can buy a whole bag of these cables from SparkFun. I went to my local Micro Center and got a whole bunch of them for like $6-7 or something, all because I didn't want to wait for the 50 millimeter show up. But now I've got more than I need, so whatever. By the way, you'll see down here I have some old prototype parts. This has an old, smaller screen in it, and see that reset button on the bottom right there. Yeah, I didn't. I coded a whole menu system for that screen, and I was like, the screen's tiny. Do they have anything bigger? And I accidentally ordered the larger screen. That's different. That doesn't match. That doesn't match at all. Whoops. And also, this is what the board looks like before you solder them together. So I'm disassembling it so I can show you what it looks like putting it all back together. So let's disconnect the little cable. It pulls right out. No effort required at all. Put that right there. That little cable stays there, and you can kind of see the captured nuts inside, which you can't take them out yet because the top and bottom are still on. The top and bottom are held together by 4 M2.5 screws and nuts, but they're not like captured. And I don't have the exact right length on this. You can see they kind of stick out a little bit. Not the end of the world. I think 18 millimeters is the correct length for my design, and all I had was 16 and 20 millimeters. And I didn't want to add thickness to this whole device, so I just went with what I had, even though it's not optimal. So yeah, check the parts list. It'll tell you everything you need to know. Okay, we got it apart. Oops, we are losing screws already. Here's the bottom part with the 2 captured little nuts right there. You can see I've hollowed it out as best as I can. You could probably make some of this less thick, but I don't know. I don't want to risk it because it's got a lot of screw threads that I don't want to lose. You can see little lines here where the solder tips will seed into if you happen to push pins through too far, but typically you won't use that. Let's see, we have the top part, should also pop off here. There we go, top part. Also has 2 captured screws and 3 little buttons right there that are just held in there by gravity. So if I tip this over and start tapping it, those will fall out. So I'm kind of holding them in right now. But those buttons, they're very small, but it did take me a while to get them right. There's very little wiggle room in between the actual physical buttons on this board and the top of the enclosure. So there's little physical buttons and a little reset button, and there's the screen. And you can see, well, maybe you can't so well, but on this side, the Stemma QT connector slides right into the feather board. Really trying to show you that right at the top. And then it slips through the pins that are soldered right there on the side. I put 2 wires through on between 2 pins, and then another 2 wires through between 2 other pins, and they just fit right in there. There's plenty of wiggle room inside the pins. I was really sweating how I was going to route these cables, and then I just decided, screw it. I'm just going to send these wires straight through the legs. So basically the first step to, now I've got this apart, the first step to putting this whole thing together is get your middle printed piece and sandwich the middle piece with the feather board. It goes in the bottom. It'll snap in. It's at least how I print it on my printer. There's the tolerances are rather tight, and when I force this in here, it makes a little snapping noise. So it should probably snap on yours as well. It's not a big deal if it doesn't. But if you're having a hard time actually fitting that board into the area allowed, then maybe your tolerances are off. Maybe your print's a little small. Maybe you should print at like 100.1% or something like that. Just try printing it again, slightly larger. The top part sits on top of the middle part. It doesn't snap in. It just kind of sits there. In between it, I have used pin headers that look like this. I am not using the standoffs that you will see on this guy. This guy has standoffs. Don't use those. They are great for when you're prototyping. They are great for when you're testing stuff. But they kind of force you to make something a certain height, and I didn't want to make the whole design that much thicker. So, it looks pretty similar, but don't do that. Just use headers. So on one side of this board, I have the headers soldered in, and then I sandwich the two boards together between the middle piece, and I solder the other side. Just be careful if you're using PETG or ABS or really anything. Your soldering iron is going to get hot enough to melt that plastic. Unless you're printing with something really exotic, your soldering iron is going to be hotter or as hot as your 3D print head. And typically it's hotter. Like your 3D print head is typically only getting up to like 190 or 200 or something like that. And your soldering iron can go much higher. I often am soldering at like freaking 300, 400, something like that. So just be careful when you're soldering this together. But that's your first step. Sandwich the middle piece and route the Stemma QT cable through the legs and then finish soldering. So you should have a piece that has a cable poking out like that, your featherboard on the bottom, and your screen on top. Step number 1. Step number 2 would be putting the nuts into the capture points here on the bottom and at the top, and also putting your tiny little buttons into the top. Now, typically, I put the top on before I put the bottom on because those buttons will fall out if you're not careful. So you take the screen and you line the buttons up with the actual buttons. So those buttons and these buttons should focus right there. Cool. Those are the physical buttons, real buttons. Overlap them. Ooh, be careful. And this should snap. Once you have it in place, should just snap. Bam. Because what's actually snapping is the board of the top board snaps into because it's soldered into the captured between the middle section. It snaps into the top section. Now the top section is kind of held in place where it should be. Like you don't need the screws yet. Don't worry about it. You could set this down. You could don't throw it. But those buttons aren't going to pop out now. In fact, ooh, you can hear them clicking. They're working, or they will work. Now, second thing that you actually need to do is slot this little guy right this way, right? You got to have the button, basically the battery slot, the two slides go side by side. So, and really this is an asymmetric design, slightly asymmetric, not super asymmetric. And you'll notice very quickly if you have the two sides not lined up. But basically your battery slot goes like that. There you go. And sometimes if you have enough of the pin headers sticking out here, it'll slot into those little rails that I've designed into it. Used to be more when this design was actually thinner, but I had to make the design thicker over time, and now it doesn't slot in there anymore. So those lines are kind of a leftover design feature, but I'm not going to take them away. They still serve a purpose. So here's your top and bottom. Put your screws. One of the nuts. Sorry. Put your nuts into the bottom piece. Well, don't put your nuts, but put nuts into the bottom piece. There you go. There you go. And now for the fun part, which is putting the dang screws back in and keeping the nuts from falling out at the same time. All right. This is I say it sarcastically. This is not my favorite part. Screwing stuff in and out of this, again, is a bit of a chore because of how tight the screw holes are, but you got to do it. So maybe I'll use a drill this time. I don't know. Yeah, let's give that a shot. Okay. All right. All these screws are in. That took a lot longer than I thought it would, but they're all in now, except for the top ones. What are we going to do here? Well, you take the little sensor board, bada bang, bada boom, and you place it in the top, in the little hat piece. What do I call this? I don't remember. Sensor cover. I'll call this a sensor cover. It goes right here. Obviously, the sensor has to go where the hole is. Duh. And then you arrange this so that the hole is facing the right way. So if you look at the screen part and then you look at the bottom and you look at your sensor hat, the sensor should be closer to the bottom screws. If I design this the way I think it did. So you plug the little QT connector, and this is actually one of the more difficult parts. You could probably just take the sensor back out, plug it in first. It's kind of hard to get your fingers in there when, am I doing this the right way? Excuse me, sir. Plug it in the right way, okay? Then put the sensor thing in there. That makes it a little bit easier. There you go. Okay, so you've got a little sensor board. There you go. A little sensor plugged in. And the cap, the little snap nut things on the side, snap lock, whatever you want to call them, they will kind of guide you. Close this up, and you push it down, and bam, it snaps on. Now, most people say, oh, that's good enough. Why do you need the screws? Well, the screws are to hold the board in place, really. They're not to, I mean, it's probably fine. You probably don't need the screws, but I designed it to use the screws, so at this point it's too late. I'm putting screws in this puppy. If I can find them all. I had 4. I swear I had 4. Now I have 3. Found it. There's the 4 screws I need. Okay. Yikes. All right, let's put the screws in. Now, if you tighten down the screws too much, you'll actually kind of pull up the sides. Right now, the sides are kind of flush with the top, which is great, especially when you first print it. But if you tighten these down too much in the center, you'll actually squeeze the center down so much that it pulls up the sides. So don't over-tighten the nuts in the center. It's completely unnecessary. Be nice to them. So let's put 4 of them in. These screws, I believe, are 8 millimeters long. All right, now the hat's on, and it's been plugged in, right? You didn't forget to plug it in, did you? Great. Now, the last step is to take your battery, which won't have the orange tape. It'll have probably translucent yellow or orange tape on it. Slide that puppy right into there. Bada bang, bada boom. And then connect it. You can actually shorten this connector if this little loop sticking out there bothers you. It's very easy to shorten these. You do probably have to buy new ends unless you cut it off at the other side and resolder it. And as soon as you plug it in, the device is going to boot up. In fact, let me do that again so you can kind of see it boot up. There you go. Okay, I guess you didn't get to see it boot up. Sometimes if you're fast enough, or if it's in a weird state, you'll actually see some of the Python lines show up for half a second before the screen is initialized. But it's pretty fast. So let me see how close can it focus. Right about there. Cool. So again, that was the disassembly and reassembly of one of these. It's really not that complicated. The hardest part probably is the soldering. Everything else is just buy the right parts and screw them together in the right order. And don't forget to hook up the sensor. If you don't hook up the sensor, this boot up, it'll just crash. It'll look for something that's not there. If you don't solder the OLED screen board to the Featherboard correctly, it'll also crash because it won't be able to find the display. It's all calling for things that are at set I2C addresses. And if it can't find them, it's just like, well, I give up. So if you do it right, it'll boot up correctly. If you do it wrong, you'll have a failure. And then you just got to take it apart and figure out what you did wrong.